Well, welcome back to our single-family residential construction series. We're now on to part 4, which is all the finishing stages. Part 4 will be broken down into 3 parts. Part A will take us from the installation of all mechanical systems, which we've seen, all the way to the drywall and painting stage. Part B will include all the interior decorative elements, the tiling, cabinetry, light fixtures, and so on. And Part C will be all the exterior finishing. So let's get started with Part A. Well, Part A of our finishing series will start with the insulation. It'll also include the vapor barrier, and we'll look at drywall, mudding and taping, and painting. Once all of our mechanical systems have been installed and inspected, it's time for insulation. This house will be insulated with pink fiberglass batt insulation, and you can see here the batts have arrived. The way the pink fiberglass batts are installed, if they're simply friction fit into the wall cavities, in this case they're 2x6 wall cavities, so this will give us about R20 insulation. Batts will also be used in the ceilings, and these will be thicker batts, typically R40 or thereabouts. The entire house will be insulated using fiberglass batt insulation. This is probably the most common type of insulation we see in new home construction. There are different kinds of material. There could be spray foam insulation, there could be rock wool insulation, and all those types of insulation are used for different applications. You might see spray foam in basements or used in vaulted ceilings, for example. It's more expensive, but it's also very effective. This house will entirely use pink fiberglass batt insulation for all the exterior walls and ceilings. One of the construction elements you'll see when fiberglass insulation is used for ceiling insulation is the presence of these styrofoam baffles. And the purpose of the baffle, if we look at the picture on the right, and this is a picture of a neighboring house, what the baffle does is it holds the insulation away from the underside of the roof sheathing. So what that does is that allows air to move in from the soffit inside the baffle, and will continue through the baffle. And if we switch to this picture, which is of our house, that air will continue to move through the baffle into the interior of the attic. And what that does is that allows for air to enter the attic space. We saw in an earlier series the presence of the roof vents when we looked at the roofing section. Well, the roof vents allow air to leave the attic space. In order for that vent to function properly and air leave that vent, air has to come in from somewhere. So it comes in from this location. So this location, the soffit, this will be covered with soffit material, which will be perforated to allow air in. So air simply moves into the baffle, into the attic space, will absorb any moisture that might have migrated into the attic, and then be exhausted through the roof vent. Once the installation is completed, the vapor barrier will be installed. In the picture on the left, you can see a roll of the vapor barrier, just plastic sheeting, and it comes in rolls like this. In the picture on the right, you can see the vapor barrier has been installed, and it's installed on the interior side of all the exterior walls or ceilings. It's either stapled or applied with sealant. You can also see the tray ceiling in the entranceway of our house. There's vapor barrier on this part of the ceiling, and there'll eventually be insulation placed above this location as well. In this slide, we can see the insulation and the vapor barrier have been completely installed. You'll notice in the insulation there are absolutely no gaps anywhere, so the insulation is complete, right tight to all of the framing, so there are no gaps for thermal bridges. You'll notice also that the vapor barrier has been completely installed, and it's stapled to all the studs. It's been sealed with adhesive in all the corners. It's been taped where there are 2 different pieces of vapor barrier coming together. And you notice all the junction boxes have been taped and sealed as well. And because the purpose of the vapor barrier is to prevent the movement of vapor, which can contain moisture from the inside of the house, which is typically moisture laden. So if that moisture in the vapor were to move through and get into the insulation, it would eventually condense. And if it condensed in the insulation itself, that would reduce the efficiency of the insulation. If the moisture in the vapor were to condense, say, on the inside of the exterior sheathing, that could lead to mold growth and other problems degrading the actual sheathing itself. So it's important for the vapor barrier to be perfectly uniform, to be absolutely no gaps, and be sealed around all corners and junction points. In this slide, we can see the installation of a different type of insulation. This is a rock wool insulation, so it's different from the fiberglass insulation we saw in the previous couple of slides. This rock wool insulation is used between interior spaces. So this is an interior wall, and the benefit of using the rock wool insulation, it has greater density than the fiberglass insulation, so it has better sound conducting qualities. In other words, it won't allow sound to pass through it as easily. So you'll often see this kind of insulation used on interior walls, separating a sleeping space, which needs to be quiet, from, say, a living space. We also know this is an interior wall because there's no vapor barrier applied to this wall, so we don't need vapor barrier between interior walls, only where there's an interior wall that touches the exterior. In this slide, we can see the drywall sheets have arrived, ready to be hung. Drywall is used in most interior spaces in the walls and the ceiling. It's inexpensive, it's relatively easy to work with, and it has good fire-rated properties, so it won't allow fire to pass through it very easily. In this picture, we can see that there's some 8-foot sheets, and these are 4x8-foot sheets, also some 4x12-foot sheets. And the benefit of using the longer sheets is the longer the sheet, the fewer joints you have, so less time and effort it takes to fill the joints and to sand them, and also fewer joints mean ultimately a smoother finish and less likelihood of cracking. One of the additional features that our house has, that not every house has, is the installation of these metal strips, sometimes called resilient channel or soundbar. And what the purpose of these strips are, it's to separate the drywall from the wood framing. So the drywall is attached directly to the metal strips and not to the wood framing itself. In any new house construction, there's always a likelihood that the wood will shrink or crack or move over time, especially in the first year or two after it's been built. So what this metal channel does is it separates the drywall from any of that movement, reducing the likelihood that the drywall might crack or shift over time. These metal bars also have another function, which is to reduce the sound transmission from one room to the other. Because the drywall is attached directly to these metal strips, any sound that hits the drywall and vibrates the drywall will not be translated directly into the wood framing and potentially to the room above, so it has a sound barrier quality to it as well. Now in our house, drywall is used in all the interior walls and ceilings, but one location where we won't use drywall will be the bathrooms or any areas that come in contact with moisture. So typically shower surrounds or tub surrounds, any area where there's possibility that the wall will come in direct contact with moisture. In those locations, a different material will be used. It'll either be a concrete board, something resistant to moisture, or in this case we've got Dense Shield, which is mold and moisture resistant. So the purpose of these materials is, if it's used in a shower or bathtub surround, if moisture got through the tiles, so through the grout joints, and came in contact with the material, it wouldn't degrade. So it would be able to handle the moisture and you wouldn't get tiles coming loose or cracking grout joints. So anywhere where there's likelihood or possibility of moisture coming in contact with the wall, drywall should not be used, and different materials such as Dense Shield should be used. Well, if we go back to the drywall installation, on the picture on the left, you can see that the workers hanging some of the drywall in the closet. In the picture on the right, the living area is mostly complete. The walls are done, the soffits are completed, as well as the ceiling. And once the drywall is up, there's no chance to make any changes inside the wall. So any plumbing or electrical or wiring that needs to be run has to be run prior to the installation of the drywall, because once it's on, any changes inside the wall become very difficult because you'd have to tear into the drywall and remud or tape it. So this is the point at which any changes that have to be done need to be done before the drywall goes in. And this is just one more picture of the drywall installation. Picture on the left, of course, drywall hasn't been applied yet. It'll be applied onto that tray ceiling. In the picture on the right, we saw this in the previous slide. The drywall is installed. One of the things you'll notice is in the installation of the drywall, the joints will all be staggered. So there's a joint in this piece of drywall here, and it runs into a solid piece here. So you wouldn't see a joint continuing along here. And that's done for the strength of the drywall and to resist any potentially cracking. In this slide, we can see the entranceway has been completed. And there's one additional feature that we've got here that's a little bit of extra work for the drywallers, and that's the installation of this box. And this is just framed in with 2x4s and then covered in drywall. And there'll eventually be some trim applied to it, and our light fixture will hang from it. And this is there simply to provide some architectural interest, but it does require a little bit of extra work from the drywallers. After the drywall is hung, all the corners need to be treated. In this case, we're going to use some round corner bead. And the corner bead is applied directly to all the exterior corners, and it simply gives a nice round finish look to the drywall. Sometimes this corner bead can be made of metal, sometimes it's made of plastic, sometimes it can be a sharp 90-degree corner. In this case, we're using rounded corners. So this is simply a way to give a nice rounded finish look to all the exterior corners. In this slide, we can see a close-up of the corner bead as well as a corner block. So in this case, we've got our nice round corner bead added here, But because in our house we'll have flat stock that will be used for our molding of the baseboard, we need a way to transition from that flat stock to the round corner bead. So the insulation of this plastic piece, which is just stapled in place, will give us a nice transition from our square baseboard to our round corners. Once all the drywall is hung, it's time for the mudding and taping. So the drywall compound or mud can arrive in a pre-mixed form or can be in a dry powdered form, and they mix it up on site. You can see some of the tape that's used for taping between the joints as well. The pictures on the right, this is simply a hopper or a way to deliver the joint compound to the tape. So as the tape is pulled through underneath the hopper, a certain amount of drywall compound is applied to the tape. That tape then will be applied directly to the joints in the drywall, and this setup simply makes it faster and easier for the taper to get the tape onto the wall. In this slide, we can see some of the progress of the mudding and taping. In the picture on the left, we can see a single coat of mud has been applied. There's taping goes along all the joints and of course in the corners. So it'll be a single layer of tape and a single layer of mud. It'll be smoothed out, allowed to dry, and then sanded smooth. There'll typically be 2 or 3 coats of drywall compound applied over top. Each successive layer will get smoother and smoother, and it'll be feathered out to make that joint all but invisible. In the picture on the right, you can see how all the joints, the drywall compound has been feathered out. So that makes for a perfectly smooth transition from the drywall itself to where the corner bead was applied. So in the picture on the right, this drywall work is completed, all the mudding and taping has been done, and it's ready for paint. And this is one additional picture of the drywall joint compound being applied, and it's ready to be painted. Now this is an attic hatch location. You can see the attic hatch here, obviously. One of the things that should happen in an attic hatch, there should be a gasket or foam seal around all the joints to prevent any more moist air from migrating up into the attic. Now these attic hatches are often just covered by a sheet of drywall or sometimes plywood. And of course, if there's a sheet of plywood or drywall over the attic hatch, then there should be insulation on the other side of that drywall to prevent any thermal bridging. So make sure there's no gap in the insulation between the inside and the attic. In this slide, we can see some of the painting is being completed. In the picture on the right, this is a living area which has been completed. You notice that the baseboard trim hasn't been added yet, and that just makes it a little easier for the painters. They don't have to worry about painting to a very finished line, which would consist of the baseboard. And that's the same with the window trim. It's yet to be applied. In our house, we've actually having the garage painted as well, which is kind of an additional feature. You don't often see that in houses. But in this case, we've got our garage painted, and it matches nicely with the interior of the house. And this slide is the last one in the first part of our finishing series. So the drywall's been completed, the painting's been completed, and we're ready for the next stage. So in part B of the finishing series, we'll look at the installation of flooring, tiles, and cabinetry. So that's coming up next.